This is a particle podcast. WA Science told different, powered by Scitech.
Please Look Up is recorded at Scitech on Whadjuk Noongar land. Good evening, everybody, and welcome to Please Look Up, the monthly podcast produced by Particle, where we take you through a guided tour of the night sky as seen from Perth, as well as taking a deep dive into some of the more out-of-this-world space news. In this episode, we'll be discussing what you can see in the night sky in the month of October. My name is Leon, and I'm joined by Beth, a professional presenter from the Scitech Planetarium. Beth, thanks for being here.
Thanks for having me, Leon.
So, Beth, as we always start these podcasts, can you tell me, as a casual observer, what sort of planets will I be able to see in the sky this month?
So there's a few. Our M planets are frustratingly away. Mars and Mercury, they're hiding behind the sun at this time of year, so we won't be able to see them.
M planets?
What's that?
I was wondering what you meant by M planets.
The ones that start with M.
Of course. So they're behind the sun, you can't see those?
Yeah, you can't see those, but you can see Saturn, Jupiter and Venus. So Saturn's really good from after sunset in the northeast until about 2 in the morning. Jupiter, you have to stay up a little bit later to catch that one coming up. But Venus, you either have to be a very late sleeper or a very early riser, because Venus is best seen just before the sunrise.
I see. Yep. You're either up very late or up very early.
Yeah.
Well, I'm more of a late person, so I'm guessing I'll probably be able to see Saturn and Jupiter up in the evening.
Yes.
I'm not a morning person, so I might give Venus a miss, but before sunrise, you said?
Yes.
If you're keen to see Venus.
Yeah, that's a good one. So if anyone's up super early, then if you see a very, very bright star in the sky, it might not be a star at all. It might be Venus.
It's probably Venus. Okay, good to know. What other interesting news? What's happening in October?
So one of the most interesting space events in October are the Orionid meteor shower.
Orionid meteor shower?
Yeah, so that is what I guess we would call shooting stars as well, but a lot of them,
yes, of course.
all peaking, so you'll be able to see the highest volume of them in the sky on about the 21st of October. So you'll be able to see them from, I think, now, when this podcast goes out.
Oh, right. So it's going for ages, but the best day is like
yes,
21st-ish.
Yeah, exactly. So you'll be able to see some activity throughout the whole of October, but it'll be getting towards its best on the 21st.
On the 21st, right. And so you said they are the Orionids. Is that because they're associated with the Orion constellation?
Well, so it looks like they come from the Orion constellation, but it's not like those fragments are actually coming from the stars in Orion.
Right.
They actually come from Halley's Comet.
Halley's Comet?
Yes.
There you go. Okay, so it's just the angle that we're viewing them at. Looks like they come from Orion.
Yes.
But Orion's not even a real thing. It's just a direction.
Yes, exactly. So with most meteor showers, they are named after the constellation where it looks like they're coming from,
right.
Because that's the easiest way to find them in the night sky. Because if you're looking up at the night sky and I say, oh, just look for Halley's Comet, but if we can't see the comet in the night sky, that's not going to be much help if you actually just want to see the meteors. Whereas
right.
It's a little easier to find Orion with his belt. So the Orionids.
There you go. So my understanding, so meteors are like bits of dust and sand as they streak across the sky.
Yes,
so
absolutely.
These fell off Halley's Comet potentially centuries ago, and
yes.
now they're arriving at Earth.
Yes. So the reason that they look like they're making light is because they're actually tiny fragments of dust and rock that are burning up in our atmosphere.
Okay, so as they streak across the atmosphere, they glow. Cool.
Yeah.
How many meteors should I expect to see then on this sort of peak day?
So about a dozen per hour. So it's not going to be like all of the stars in the sky are moving. It's not going to look like that, but it will be, hopefully about 12 in an hour, which is pretty good for a meteor shower.
Yeah, what's that, once every 5 minutes or so?
Yeah.
All right. When's the best time to look then?
So this is another one for our night owls out there. After midnight, but before sunrise. Yeah.
All right, my time to shine.
Absolutely.
Okay, is that just because of the position of Orion in the sky?
Yes, it's partly because of that positioning, and also obviously it's a little bit easier to see all of the stars when you don't have things like the moon in the way. So making sure that you catch your timing right is important for general light. And the same thing as well, if you're in a city, there'll be lots of light pollution. So if you can try and get out of Perth on the 21st or out of whichever city you might be in.
Good stargazing always begins with get out of the city.
Absolutely, including for meteors.
Fantastic. All right, so meteor shower, lots to look forward to there. Anything else in the month of October?
Yes, super exciting, solar eclipse.
Excellent.
But we can't see it from Australia.
Damn.
Yes.
I had a feeling we would know if we could see it from Australia.
We would. So it is a solar eclipse on the 14th of October, and that is passing through the Americas. So it's looping all the way down through North America, and it's even catching a little bit of South America as well.
Ah, there you go. And so solar eclipse is when the moon passes in front of the sun and the shadow is cast on the Earth.
Yes.
Yeah. Oh, that's exciting. But yeah, no, not for us. Although I do seem to recall, because of the way the moon's orbit works, usually when there's a solar eclipse, then a couple of weeks later there's a lunar eclipse as well. Are we going to get one?
Yes, we will. So it's not an amazing lunar eclipse. It's only about 6% of the moon that's going to be in shadow.
Oh, no.
So it might just look like a slightly small moon. But we can see it again from 2 till 5 a.m. on the 29th. So a slightly disappointing lunar eclipse for us compared to the solar eclipse in America on the 14th. But I mean, we had our big Exmouth eclipse, so it's their turn, I guess.
Yeah, I guess so. So even if you're really determined, if you want to stay up till 3 a.m. to see 6% of the moon be covered by shadow.
Yeah.
All right, but well, if you want to, you certainly can.
Absolutely.
All right. Well, what about any interesting constellations? What's exciting this month?
So the Great Square of Pegasus is visible in the northern night sky. And the rest of Pegasus as well. It's just the square is sort of the easiest bit to spot.
Right.
What's quite fun about that is that one of the stars of the square isn't actually part of Pegasus. It's part of Andromeda, which is the neighbour constellation.
Okay, so let me get this right. So Pegasus is the constellation.
The constellation is Pegasus, yes.
Right. But because of just the stars in it, so we're looking for a pattern of stars that looks like a square, is that right?
Yes, it looks like a giant square, and then coming off that square, there sort of looks like if you draw a very poor dot to dot and use a lot of imagination, there is a horse's head and a couple of front legs coming off one side of the square.
Right, okay. Oh, and the square is like the body of this Pegasus.
Yeah, sort of like the chest of it.
Right, which I remember Pegasus is the horse with wings, isn't it?
Yes, so Pegasus is the winged horse. Wings, not in the constellation. But it could just be a horse, but the Greeks were lovely and creative. And a lot of the constellations in that area are all to do with the same Greek myth, the same story. So Pegasus was first ridden by Perseus, who was the one who was famous for slaying the Gorgon Medusa. In fact, that's how Pegasus came to being in the mythology, sprung forth from the Gorgon's neck, which is,
oh wow.
I know, yeah, those Greeks.
I hadn't heard that part, because I remember the Medusa is the one with snakes for hair.
Yes, so when she got her head cut off, a horse appeared. Because mythology. And then Pegasus and Perseus together helped rescue Andromeda, who's another constellation, from Cetus, another constellation.
Wow.
So the whole story is up there.
It's a story, I think it's a story for another day, but and so you said one of the stars in the square of Pegasus is actually part of the Andromeda constellation?
Yes, it is.
Right. That's how we use it to make the horse anyway.
Yes, we use it to make the nice big square because it's a big obvious square.
Yep, very good. I did see, because the name's ringing a bell now, is it 51 Pegasi that's the really interesting one, or 51 Pegasi B or something like that?
51 Pegasi B or Pegasi?
I don't know.
I don't know. I'm not Greek. So 51 horse star. Well, no, it's not actually a star. 51 Pegasi or Pegasi B was the first exoplanet we ever found around a sun-like star.
Right. Well, yeah, okay, so that's why it's ringing a bell.
Yes.
So the star is 51 Pegasi, and then the planet is called 51 Pegasi B.
Yes.
Right, and it's the first planet found around a sun-like star, did you say?
Yes, so an exoplanet is just a planet that's been found outside our star. Like, it's not orbiting our star, it's orbiting a different one. Mm-hmm. And yeah, it was the first one we found orbiting one that's like our sun.
Wow, how did they even find a planet like this?
So they found it using what's called the Doppler method. The Doppler method's a little bit weird. So when you have a planet and a star, the centre of gravity between the two of them, because they're both pulling each other with gravity, because everything has gravity, but obviously the lesser weight is not going to be, or the lesser mass, sorry, is not going to be able to pull the greater mass as much as it would be the other way around. Yeah. So that centre of gravity is normally actually somewhere between the two, but when you've got a massive star, that centre of gravity is sometimes inside the star.
Much closer to the star. Yeah.
Or not even much closer. Sometimes it's actually inside.
Oh, okay.
So it means that instead of them both orbiting a central point, which is what happens when you've got two stars that are gravitationally attached to each other, when you've got a star and a planet, sometimes the star is kind of orbiting a slightly off-centre point because of gravity, and it makes it look like it's wiggling. So we can use the Doppler effect and we can detect that wiggle of a star, and normally what that means is that there is a big planet pretty close to the star.
Right. So the analogy I'm sort of thinking of is like the, when you see the people doing the shot put and they're swinging around, and so that they're swinging the shot put around, but because the shot put is so heavy, it's sort of swinging the person around too.
Yeah, exactly like that. But if you had a really small shot put, so if you tried to do it with a table tennis ball's not really going to move.
Inertia,
but if you tried to do it with a medicine ball, you would have to hold the medicine ball a lot closer, or, you would be moved a lot more by you trying to spin it.
Right, I see. And so when we look at the star, and if it's being shaken around by a planet,
yes,
we can detect that in the light coming from the star by the Doppler shift.
Yeah, we can detect the star doing a little jiggle.
Wow, that's really cool. And so the Doppler shift is just that sort of neural sound that...
Yeah, absolutely. The ambulance.
Yeah, I guess it'd be, if it's moving in a circle, it'll be going towards and away from you for a while.
Yeah, exactly. So with light, it works a little bit. It works very, very in a very similar way to sound, but it just changes the shift a little bit.
Yeah, okay. I think I follow along enough there.
Yeah.
And so you said it indicates must be extremely close to the planet then. So to the star. How close is this planet then to the star?
It is ridiculously close. So in our solar system, the closest that Mercury gets to our sun is 47 million kilometres.
Yep.
This planet, 51 Pegasi b, is 8 million kilometres away from its star.
Wow. So it's like, what's that, a tenth, maybe about a fifth the distance?
Yeah, exactly. Yeah. And it's likely to be a lot larger than Mercury as well for it to have that, for it to be able to exhibit that Doppler effect, which is how we found it.
So if it's pulling it off course, is it like the size of Jupiter or something like that?
So 51 Pegasi b, it's big, but it's about half of the mass of Jupiter. So it's not as big as Jupiter, but it is bigger than Mercury.
Massive.
Yes, absolutely.
Still massive. How is that possible then? Aren't like Jupiter-sized planets made of gas and like really fragile?
Yeah, so we think that with planets like this, they probably started to form a lot further away from their star, but got gradually pulled inwards by that gravity. So we've found quite a few examples of what are called hot Jupiters, which are those gas giants that they form quite far away from their star, but then get pulled inwards, getting really hot.
Wow.
Yeah.
And so 51 Pegasi b is the first example of a hot Jupiter.
Yeah, absolutely.
There you go. Well, I guess that begs the question then, did this happen to the Jupiter in our solar system? Did it move close to the sun?
We think it did. So we would call it the Grand Tack, which it's called tack because of boating terms.
I vaguely remember that.
Yeah, when you tack on a boat, it's either moving into the wind or moving away from the wind, and anyone who likes boats is going to write in and tell me I'm wrong, whichever one I say. So it's something to do with boats turning, but we think that Saturn actually prevented Jupiter from becoming very hot like this one.
So it didn't let it pull all the way in. Fall all the way in, rather.
No, so Saturn just being there and also being a large planet actually pulled Jupiter back to a stable orbit.
Huh, that's interesting. Because, well, I guess if Jupiter kept spiralling into the sun, there's a good reason to think that the Earth wouldn't be the way it is today.
Oh, definitely not. I mean, the Earth might have been, we might have been caught by Jupiter. We might be
a moon.
Yeah. Might not be our own planet at all. So I'm quite glad that the Grand Tack of Jupiter was stopped by the anchor that is Saturn.
That's fascinating. And yeah, we can see an example of that in Pegasus in our sky.
Yeah, absolutely.
Delightful. That's really interesting.
Yeah, we don't know what might happen to Pegasi b, so 51 Pegasi b, sorry, because it might indicate to us what could have happened to Jupiter. So we'll continue to keep an eye on it. Who knows in the future whether it'll disappear one day and we'll stop seeing that Doppler effect because the sun will have swallowed it, or whether another massive planet will come along in that solar system and pull it out again. Yeah. So it's pretty exciting to keep an eye on.
That is pretty exciting. I guess let's leave that sort of space behind for a while. Is there any other interesting big news in the world of space.
Yes, so there is an alien come to Earth. No, not really. No, okay. So what we have is we sent a spacecraft up into space. It was called Osiris Rex, and it's come back. It's very exciting.
So we sent it out, and it's come back. Yeah. Cool. I was going to say, I've seen those pictures from that silly Mexican tribunal thing or whatever.
No, this is not the Mexican affair. No. This is Osiris Rex.
I have heard of Osiris Rex. It's a weird acronym, isn't it?
Yes. So it stands for Origins, Spectral Interpretation, Resource Identification, Security, Regolith Explorer, or Regolith. Space words. People like to pick the difficult ones to pronounce, I think. I think they do it deliberately.
It's like the surface material of something, is it right?
Yeah, so regolith is just stuff. It's genuinely the easiest way to describe it. We have it on Earth. It's not a space-specific thing. It's just any loose rock, mineral, or glass fragments that are just around. So I guess it's sort of like, you might even call it like scree on Earth, like on a rock face. It's just the dusty stuff. Material. Yeah. Right. It can be mixed in with soil as well, but it's just loosely packed bits.
Material. Yeah, okay.
Yeah.
So the fact we're talking about this suggests, has Osiris Rex had something to do with that? What's its purpose?
Yes, so what we did with Osiris Rex is NASA sent it to visit an asteroid called Bennu, which is
Bennu, did you say?
Yes, Bennu, Bennu.
Right.
All of these are named after Egyptian mythology, so we've moved on from Greek.
Right. Yeah, I recognised Osiris. I haven't heard of Bennu.
So Bennu is the son of... so Osiris is the son of the sun god Ra, and Bennu is a sort of Egyptian god bird linked to the sun. Basically, people think that it might be the basis for the Phoenix myth, but there's also like a whole thing where Bennu is the soul of Ra, so Osiris is kind of visiting...
ancient mythologies are fun, but you shouldn't take them too seriously.
No, absolutely.
So Osiris Rex went to literally the asteroid called Bennu.
Yes.
And what did it do there then?
So it was in orbit studying the surface using different technologies. So, taking photographs. I can't remember if it was X-rays or some different kind of ray that it was using to investigate it. But then after a couple of years, it took a sample from the surface of this asteroid. So it took a sample of that regolith.
A sample?
Yes.
Just as easy as that, is it?
No. Well, it was very difficult, so it was very, very exciting. So in taking the sample, it grabbed 250 grams, but when it did that, it blew up, I think, 6 tons of dust off the surface.
Wow.
So that sort of tells you a little bit about the impact that this can have.
Right. So it was orbiting, and then it just kind of dropped down and snatched a bit off the surface and left. And in doing so, it just dislodged another 6 tons of material.
Yes. Yeah.
That's pretty nuts. And why do that?
Well, so we want to know what's going on in the surface, there's so much detail that we can get from having a physical sample, because this asteroid, there's only so much that we can ever do with pictures, even if they're pictures, very fancy pictures using X-rays or gamma rays or anything. So when we have a physical sample, we can do chemical tests on it. And so we know from some of this imagery that we've gotten that this asteroid is carbonaceous. Now, what that means is that there's a lot of the molecules on its surface that are essential to life. So they could be organic molecules. Not organic molecules in the sense of, like, you buy it in the organic section of the supermarket, not like that. No, but organic as in organic chemistry.
Yeah, like things with carbon, methane, and amino acids and things like that.
Yes, absolutely. And so because we think that this asteroid is potentially older than planet Earth, it could be a bit of a time capsule into our solar system. And also, it could even, if we find life on this asteroid or evidence of that there might have been life near it, that's very exciting.
That would be exciting. What a day, hey?
I know.
So it's a time capsule to our early solar system. So I guess, tell me a little bit more about Bennu then.
So it's basically just a big pile of rubble that's being held together by gravity. And we think that it might have formed from debris that was blasted off a protoplanet. So A protoplanet is...
That was going to be my question.
Yeah, you just throw out the, exoplanet, protoplanet, planet, what do they all mean anyway? Don't even get into that because scientists are still arguing over what a planet actually is. But a protoplanet is a smallish object from billions of years ago. And we think that some of those are what merged together to form our current planets.
Right, okay, that's what I thought. The name protoplanet suggests that. Okay.
It's pre-planet.
Pre-planet, yep.
Yeah.
Okay, so planetary formation is basically like from little things, big things grow.
Yes, absolutely.
And you say Bennu seems to be made up of material that was blown off a protoplanet, did you say?
Yes, we think so. We think that, so you've got those protoplanets, obviously in early solar system, those protoplanets are doing a lot of crashing into each other. Mm-hmm. Some of them are crashing into each other and merging and becoming planets. Some of them are crashing into each other and just breaking up into smaller pieces.
Right.
And even when the ones that crash together to make new planets, I'm saying crashing for a reason. It's not a gentle process. So yeah, a lot of that debris, those like loose bits of material get thrown off into the solar system, into space, and then from little things, big things grow. So those small pieces clump together, and sand forms together into rocks, rocks form together into boulders, boulders form together into asteroids.
Yeah, right. Okay, I see what you mean. So yeah, it is this very much a growing process.
Yeah, so it is. We are a little worried about some asteroids. People are always a bit worried about asteroids crashing into Earth. Having said that, there are things that crash into Earth all the time. We spoke about them earlier, meteor showers. So if they're small enough, those asteroids, they become meteors when they hit our atmosphere and they burn up most of them.
So does Bennu have a chance of hitting Earth?
Yeah. Don't worry, it's not for a long time and there's not like 100%. It's not definitely going to crash into us. So in between the years of 2178 or 2178 and 2185, there's about a 1 in 1800 chance.
Oh, okay.
Yeah.
Oh no, you know what this is going to be? This is going to be we'll let the future generation solve the problem, and it'll just keep getting pushed down the line until
until 2177, and then they go, oh no, Bennu is coming.
So 1 in 1800 chance between those years.
Yeah,
that's still pretty slim, and that's just from like modelling its orbit now and seeing where it will be in the future.
Yeah, absolutely. And with space, who knows? Unexpected things happen all the time, and yeah, so we have no way of knowing for definite, which is why there's that 1 in 1800.
Gotcha. So Osiris-Rex went to Bennu, took a sample, brought it back to Earth.
Yeah.
And what happens to this sample now?
So it's being opened up in a nitrogen environment. So nitrogen is very unreactive.
Yes,
it's the stuff they put in crisp bags. It's not air. It's actually nitrogen.
Yeah, that's right. I've heard that. Yep.
Yeah, keep them preserved. So to protect it from like different contamination. And
if you fill it with like oxygen, you get the meteoric equivalent of going off.
Yeah, exactly. Or, even just rust. So rust is oxidation. That's what happens when iron is exposed to oxygen.
Right.
So we've opened it in a nitrogen-rich environment so it doesn't get contaminated by biological or chemical substances.
Mm-hmm.
So lots of different scientists across the world are going to spend years and years studying it and sharing it with different agencies so that we can learn as much as we can from it.
Wow, there we go. There we go. All right, so we'll learn a fair bit about Bennu. Is Bennu a typical asteroid then?
Sort of. It's typical for its type, and its type is the most common. So there are 3 main types of asteroid.
All right.
So you've got C-type, carbonaceous, which is what Bennu is, and about 75% of all asteroids that we know of are carbonaceous. Then there's the S-type, which are stony or silicate, so they're very, very rocky, and there's also M-type, which are metallic. So yeah, there's those 3 different kinds of asteroid. Within those, Bennu is part of the most common one.
Gotcha. Bennu's carbonaceous, right?
Yes.
C for carbonaceous, S for stony, and M for metal.
Yeah.
Okay, there we go. I've just learned that. I don't really know much about the different classes of asteroids, or that they even had classes.
Yeah, you'd think that it's just all space rocks, but no, what kind of rock is in there is important. So yeah, you've got the C for carbonaceous, so with those organic chemistry molecules. You've got S, which is stony, silicate, rocky, and M for metal. Mm-hmm. But speaking of metallic and metal, I know, it's very exciting. The Osiris-Rex mission is ending because it's come back to Earth, but Psyche is about to start.
Psyche?
Yes.
This has taken a turn.
Yes, so not Psyche, as in we're not suddenly doing a psychology podcast, don't worry.
Okay.
So it's another NASA mission, also named after Greek gods because they keep doing this. So it's launching on the 5th to visit an asteroid, which is also called Psyche.
Right, that makes a lot of sense. The 5th of October.
Yes.
That's very soon.
It is very soon.
That's quite poetic. As one mission ends, another one begins.
It is. It's beautiful. It's almost like they timed it like that. I genuinely don't know if they did. I really hope that they did, but...
I think the orbits would have more to say about it than our desires.
That's true.
Okay, so it's a spacecraft called Psyche going to an asteroid called Psyche.
Yes.
Yep. And what's there? Why are we going to Psyche?
Well, so this all links together because Psyche is an M-type asteroid.
Right.
So it's very, very different to Bennu. It's also a lot bigger. So Bennu is about 500 meters across. Psyche is 220 kilometers.
Whoa.
Yes.
That must be one of the largest asteroids we know then.
I expect so, yeah. I mean, that we know so far.
Yeah.
Obviously, everything with space has that little caveat of so far that we know.
So 220 kilometres across, and M-type, so it's metallic.
Yes, so it's got lots of iron, lots of nickel, lots of metals.
There, okay. So I'm going to guess this has a very different story than Bennu. If Bennu was blasted off the surface of a protoplanet.
Yes, so we still think that it may have come from a protoplanet, but we think it might have been the very core. So Psyche may have come from deep within one of those protoplanets. So like on planet Earth, our core is an iron core.
Yep.
So if we have these asteroids that are made of a lot of iron, there's a good chance that maybe that came from what would eventually become the core of a planet rather than something that would eventually become the surface.
Right, so we're imagining like a protoplanet that would have maybe had a metal core and then has undergone some sort of really big collision, and that's essentially just blown the outer layers off, and what's left over is this metallic object we now call Psyche?
Well, not just that, but so these collisions, they can get big enough that they actually melt the protoplanets, and so the metal then sinks.
And that's why they have the metal core in the first place.
Yes, yeah, absolutely. And that is what happens, or it's our best explanation at the moment for why Earth and the other rocky planets have those metallic cores that they do.
Right, and so how much metal does Psyche have then?
So we think that it's about 50% metal. So mostly iron and nickel, which would mean if you imagine a 100-kilometre sphere of iron, which we probably can't, but that's okay. But it's more than we've ever mined on planet Earth.
Huh. Yeah, well, yeah, when you put it that way, 100 kilometres is very large.
Yes, it's very, very large. Well, the atmosphere is only 100 kilometres thick, which you say only kilometres, but then actually if you think about an iron sphere that stretches from the surface of planet Earth to the atmosphere to space, that's how big this sphere would be.
Right. And then suddenly it becomes a lot easier to visualise how it's more iron than we've ever taken out of the Earth before.
Yeah, absolutely.
Okay, because, you kind of lose perspective in all of that when you say, it's 200 kilometres across and it's about half iron and nickel.
Yeah. Yeah, so imagine you're standing at the bottom looking up into the sky, but you can't see the sky because there's a big iron mass in the way.
Right, so there's a lot of stuff there.
Yes.
And so when's Psyche going to get to Psyche?
2029. Yeah, stuff is very far away, and because we have not unlocked speed of light travel yet, we're not very fast at getting there. And in fact, space is so big, even once we do have speed of light travel, if we ever...
Still going to take
a very long time. But yeah, so it's going to do something pretty cool. So Psyche is going to get a gravity boost from Mars. So basically it's going to fly past Mars in such a way that the gravity of the planet will actually speed it up.
Yes,
and
I
sort
have
of
heard
slingshot
of doing this. Yeah, the slingshot. Yeah, that's really cool. Okay, so it's going to Mars on its way to Psyche.
Yes, so it's not going into space to research Mars. That's not its purpose. If it catches some information on the way past, I'm sure we'll be happy with it. But that's not the purpose of its mission.
Yeah, exactly. It's just there to get a boost of speed.
Yeah.
Yep. And how's it going to study Psyche when it gets there then?
So it's got a few things. First up, a very fancy camera. Very important. Yeah.
You wouldn't go there without a camera.
No, we need some good normal pictures of it. And then it's also got an even fancier camera called a gamma ray spectroscope, which it's kind of like a camera, but it takes pictures using gamma rays instead of visible light.
Right.
Yeah.
It's as simple as that?
Yeah, just like that. No more information.
Why gamma rays? Does the asteroid emit gamma rays?
So when you're in space, everything in space is being bombarded by cosmic rays. So those hit the surface of the asteroid so hard that it then gives off gamma rays, which that spectroscope can detect.
Right.
So the energy of those gamma rays, it depends on what the asteroid's made of, so that we can figure out what it's made of by looking at those gamma rays.
That's so clever.
It's so cool.
That and that we're using the cosmic rays as the initial source of that energy.
Yeah, so we don't need to send a gamma ray emitter into space.
No.
So it's not like the asteroid's not like radioactive. It's not uranium glowing, but
the actual source of the energy is the cosmic rays, and we're just exploiting that. With the gamma ray spectroscope.
Absolutely.
Huh.
So it is kind of just a fancy camera, but
I guess so.
Yeah, because a normal camera works by detecting different energies of visible light. This works by detecting different energies of gamma rays.
Makes sense. Cool. So fancy cameras on board. Anything else?
Yes. So there's a magnetometer or magnetometer or magnetometer, which I think sounds like some sort of 50s childhood toy.
I've always called it a magnetometer. But
That's another option I hadn't even considered. But that just measures the magnetic field, if it has one.
Pretty self-explanatory, isn't it?
And then lastly, it has a radar, but the radar is more to... It tracks the motion of the spacecraft around the asteroid, but as it's in orbit, the gravity pulls the spacecraft in different directions depending on like how the mass is distributed.
Right.
Because if you've got a planet, it's a nice sphere, and so, well, mostly, it's a nice sphere, so the mass is fairly evenly distributed throughout a planet, whereas when you've got sort of potato-shaped asteroids, that mass can be different. It can also be way more dense at one end, way lighter at another, so it can change how the spacecraft will move around the asteroid. I
see what you mean, yeah. If you've got like a real big mountain over there that's slightly heavier, it might slightly pull the spacecraft in that direction.
Yeah.
And the radar can be tracked to detect that.
Yeah, absolutely.
And you just work backwards to figure out the distribution.
Yeah. It's sort of, it's like drawing a picture of the outside of it by your wiggle.
Yeah, that's really cool.
Back to the wiggle again.
Yeah.
So much in space is just, look at that wiggle. Ooh, that's exciting.
Yeah, interpreting wiggles as groundbreaking new discoveries.
Absolutely.
I think that's the perfect place to end. It's been a time and a half. Thank you so much for being here on Please Look Up today, Beth. It's been a pleasure.
Thank you for having me.
That's it for this episode of Particles Please Look Up. We'll see you next month where we talk about the night sky and the space news for November. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.